Okay, so this cheat sheet has to be handwritten. Cram as much stuff as you want, examples, formulas, whatever you want on there, but it must be handwritten and you can use it on the exam. Okay, so let's start with interval notation. So less than or equal to 2, so that would be from negative infinity to the lower bound. 2 is the upper bound. It's inclusive there. It includes 2, so it's going to be a bracket. Infinity is always parentheses. Graph the set. So if you have it ordered like a number line, let's see, let's kind of put some of these values there. Negative 3, 0, 4, and 5. So if I kind of think up above for a second, so from 0 to 5, so 0 to 5, something like that, closed circle. From negative 3 to 4, something like this, open circle. Okay, so union means not just the intersections. The intersection would just be this, right? Just from 0 to 4, not inclusive. But because it's an OR statement, it means this all the way to this, all that is going to be solutions. So, or either one. So it's not just the overlap. The and would only be in there. So I would write my final answer in interval notation. It would be from negative 3 to 5, bracket, parentheses. Okay, you want to simplify these. So if you don't know the prime factorization of those, that would well, be nice. So 2 times 27, 3 times 9, 3 times 3. So I have 3 3s and a 2 left over. So that's going to be equal to 3 cube root of 2's minus 2 times 8, 2 times 4, 2 times 2. Got a group of 3 2's with a 2 left over, so this is going to be 2 times cube root of 2. 3 times cube root of 2 minus 2 times cube root of 2 is 1 cube root of 2. Again, 48, I don't know the prime factorization there, so let's just do 2, 24, 2 and 12, 2 and 6, 2 and 3. So I've got a pair of 2's, because I'm looking for pairs with the 3 left over. So that's going to be 4 root 3. The x squared is going to come out. That's going to be absolute value of x. The y is going to come out. That's going to be absolute value of y times y still left over. 1's y still left over in there. It's actually okay if you don't put absolute value y because we still have the y left over in there. It's actually okay. Negative exponents, you got to flip the fraction inside of there, so it's going to be 49 over 25 to the 3 halves. I'm going to do the root first, so second root is the square root of each term, so that's going to be 7 over 5. Still has to be put to the third power. Wow, I think that's 289, but I'm not totally confident, so 49 times 7, 63, 6, and 28 is 343. 343, that's what it is. Okay, so 343 over 125, I think that's good enough. Factor with the leading coefficient there, so you might want to know the AC method. Let's just do that just to be sure. So A times C is AC would be 24. So factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6, and they have to add up to be 10. All of them are positive, so it's got to be 4 and 6. So I'm going to split up that middle term with that 4 and 6. I still have the 8x squared. One of these is going to be plus 4x. One of these, sorry, 4x. One of them is plus 6x, and then plus 3. So I split up that middle term to be 4x plus 6x using those factors. Do factoring by grouping, so the first two terms go together. Pull out the GCF, that's 4x times 2x plus 1, and plus 3 times 2x plus 1. 2x plus 1's match, so we're going to regroup into 4x plus 3 times 2x plus 1. And it doesn't say solve, just says factor. We're done. know your difference of cubes formula. I believe it's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So a would be 2x here, and b is 3. So it would be 2x minus 3 times 2x squared, which is actually 4x squared when you square the 2 and the x there, 4x squared, plus 6x plus b squared, which is 9. And we're done. We just had to factor it. Factor it by grouping. Because the negative, I'm just going to regroup it. 3x cubed plus 5x squared plus negative 6x. Notice I'm not changing the sign of anything here. Pull out the GCF. I think it's just x squared times 3x plus 5 plus negative 2 times 3x plus 5. 3x plus 5 is match. We're going to regroup. We're not done yet though. X squared minus 2, 3x plus 5. I think we actually are done. X plus square root of 2, x minus square root of 2. I wouldn't expect you to go that far. You could though. Least common denominator. Okay, so we might want to. So this is first things first. You got to flip this, right? That's going to be flipped around, and factor everything you possibly can, right? So put parentheses around that. So that first fraction is going to be the numerator is going to be 2y plus 3 and 2y minus 3. Denominator is 2y minus 3. I'm going to change this to a times. So now we're multiplying. If I factor the denominator, that's going to go up in the numerator because we're divided by that fraction. So that's going to be x, it looks like plus 2 and x plus 3. That one's a little tougher to factor. You might have to do AC. You might be able to guess and check it. Let's see if we can kind of do that off to the side here. So that would be like, what did you say, 2y, and then y, and then it's either 5 and 3, or 3 and 5, or 15 and 1, or 1 and 15. Those are my options, really. It has to add up to 13. So this one doesn't work. 10, oh, I think I like that. Okay, so I think that's going to work. So plus 3 plus 5. 3 plus 10 is 13. I think that works. So x plus 3 times x plus 5. Cancel everything you can. X plus 3's 2y minus 3. I think that's it. So we get 2y plus 3 times x plus 2 over x plus 5. To add up these fractions, you're going to have to get the same denominator, which means this one's missing an x minus 3. I hope you see that. So this is going to be 1 over x squared minus 9 plus 2x minus 6 over x squared minus 9. If I add the numerators, I get 2x minus 5 over x squared minus 9. We could write that as x plus 3x minus 3 as well. Going to solve equations involving fractions. Some might have no solutions. Could be any kind of root here. You could even have a fractional exponent. Because it's an equation, what I would do if I were you is multiply everything by the GCF here, or the LC. Let's see, the lowest common denominator, which is x minus 4. So I'm going to multiply every term by that. Just kind of distribute that to everything. So I get 2x minus 8 plus 5 equals x minus 4 cancels, x plus 1. Now you're just kind of solving this. You get x minus 3 equals 1, so x equals 4. The only thing you have to be careful of is extraneous solution. So therefore, there is no solution to this problem. The reason is, if you plugged it back in, what would happen? The denominator would equal 0, which is a no-no. Denominator cannot equal 0. 4 minus 4 is 0, so there's no solution. Even though we did no mistakes, we didn't really make a mistake in solving that problem, that's exactly what would happen there. This is another one of those difference of cubes. I don't know if the other one was sum. This is difference. So we'll factor it, and then we'll use that to find the solution. So this would be, well, first let's factor, it's not difference of cubes. I don't know what I was thinking. I saw 125, I guess. Let's take out the GCF. That should make our life easier. X squared minus 25. Oh, this is easier. So much easier. Difference of squares. So our solution is x equals -5 and x equals 5. Two solutions. This one, let's get the 64 on the other side. So we get 2 times x to the 5/3 equals -64. Divide by 2, get x to the 5/3 equals -32. Put both sides to the reciprocal power, which would be the 3/5 power. Get x equals, the fifth root of -32 would be -2, so -2 to the 3rd, which should be -8. Wow, so we got to do a lot to solve this one, I guess. So you're going to find AB, the distance, using the distance formula. So that's going to be x2 minus x1, so 7 minus 1 squared plus y2 minus y1, so 4 minus 1 squared. 6 squared is 36, plus 9 is 45, square root is 45. Square root of 45 might simplify, so if you do kind of a prime factorization, which I have to kind of see. So I know 3 goes in there, 3 times 15, 3 times 5. So pair of 3's with a 5 left over. So that's, if you wanted to write this, this is 3 root 5, although you could leave it like that. And for this particular problem, I'll show you why in a minute. Let's do AC. So that would be AC is 7 minus 1 squared, very similar to the first one, plus, I guess, 4 minus 7 squared, which is 6 squared, which is 36, minus -3 squared, which is 9. Oh, wow, we get square root of 45. Which we just figured out is 3 root 5. And then BC is equal to, let's see, so that would be, oh, that's interesting. So 1 minus 1 squared plus B and C, 1 minus 7 squared, which is 0 plus, so square root of 36, which is 6. Okay, so we have proven that this is definitely isosceles because two sides are equal. So there's the right triangle. Wow, so very similar problem. So you have to be good at the, by using the Pythagorean theorem. Converse of the Pythagorean theorem. Okay, so let's do AB again. So AB is going to be the square root of, let's see, 4 minus 5 squared plus 3 minus 5, which is square root of 1 squared, or -1 squared, which is 1, and -2 squared, which is 4. So 1 plus 4 is 5. Okay. AC can be 4 minus 0 squared. plus 3 minus 5 squared. That's going to be 16 plus 4, which is 20, so square root of 20. That might simplify. Pair of 2's with a 5 left over, so we could write that as 2 root 5, although you might not want to. BC, square root of 5 minus 0 plus 5 minus 5. 25 minus 0 is 25, so square root of 25, which is exactly 5. So using the converse of the Pythagorean theorem, so I'm going to say this looks like the biggest side, so I'm going to say square root of 5 squared plus, I'm going to simplify, I'm going to use this instead. I think it's just going to be easier here. Square root of 20, there's a 20 there, squared, should equal 5 squared, right? The longest side is that one. So that would be 5 plus 20 equals 25. That's true. Yes, we have proved. Find the area of the triangle. Oh, well, so if you draw this triangle, it's going to be, one side square root of 5, one side square root of 20, and this side is 5. So the formula for area of the triangle is 1/2 base times height. So 1/2, I guess, square root of 20 times square root of 5. So that's square root of 100. So 1/2 square root of a 100, which is 1/2 times 10. Half of 10 is 5. So the area is 5. That's our final answer, our 5 square units. So we're going to test for symmetry. So I think the test for symmetry, we can plug in negative x and see if everything remains the same. So we get negative x to the 4th plus negative x squared. And that really is x to the 4th, right? That's an even negative number to the even power plus x squared. That's the same equation. It's the same. So this does have y-axis symmetry. So it does have that. If you plug in negative y, so there is no x-axis symmetry. If you plug in both negative, because it's not the same equation, that's always negative there for y. Plug in both, the left-hand side changes sign, the right-hand side really stays the same. So this is no origin symmetry here. Complete the square, identify the center and the radius. So this actually isn't as bad as it looks, I don't think. X squared plus, let's group the y, so there's no x's to group it with. So y squared plus 6y plus blank equals, let's move the 2 over by subtracting, so negative 2 plus blank. Half of 6 squared is 9, so I'm going to add 9 to both sides. So we get x squared plus y plus 3 squared equals 7. So our center, our h and k, if they asked for it, I don't remember if this one did, is 0, negative 3. And the radius squared is 7, so radius is square root of 7. I don't have to worry about plus or minus because it's a positive distance, the radius is going to be positive. And adjust your window. Okay, so get your calculator out. Let's try this one. Okay, so go to graph page, x to the 3rd minus 4x, and then x plus 5. Looks like they cross right there. I'm just finishing up. It'll take a second. Then you, so go to points and lines, intersection point, and just click the two graphs, and that'll give you your intersection point. So, so 2.63 comma 7.63. And the question asks for, do these, if so, what are the points of intersection? So there they are. That's it for this screencast.